Okay, let's solve some equations involving surds. So when it comes to solving equations with surds, there are a couple of tricks that we need to employ. So let's start off with a simple one and we'll work our way towards some more complicated ones. Here we have an equation where we have the square root of 5x equal to the square root of 2x plus the square root of 7. Now, we cannot just treat these as coefficients in front of the x, because we can't say that the square root of 5 take away the square root of 2 is the square root of 3. Right? That's not the way it works. So what we need to do is we need to isolate x on the one side and anything that doesn't have an x on the other side. So we'll get square root 5x minus square root 2x equal to square root 7. Right? From here, we can pull x out as a factor. And what we're left with is square root 5, take away square root 2. Okay, we'll see those are two different surds. We can't combine them. This is equal to square root 7. Now, to isolate x on by itself, we would need to divide both sides by square root 5, take away square root 2. So we'll get x is equal to square root of 7 divided by square root 5, take away square root 2. Now, whenever we're solving an equation, we try to always give our answer with a rationalized denominator. So using what we've learned yesterday, to rationalize this denominator, we need to multiply it by its conjugate. So we'll multiply this by square root 5 plus square root 2 over square root 5 plus square root 2. So at the top, we're going to get square root 7 times square root 5, which is square root 35. And that's going to be plus square root 7 times square root 2, which is square root 14. And we'll divide that by, we're going to have square root of 5 times square root of 5, which is 5. And then we're going to take away square root 2 times square root 2. Right, remembering that the middle term is going to cancel out, and that's the reason we use the conjugate. So 5 take away 2 is then just 3. So there's our answer. Okay, let's look at another example. Here we have a set of equations, right? And we're asked to solve simultaneous. Here's equation 1 and here's equation 2. Now, when we get asked to solve simultaneous equations, we are usually asked to give both the x and the y, both values. Now, if we have simultaneous equations with surds, right, what we'll try to do is, if we're able to isolate one of the variables, we can do that. Alternatively, we can look at trying to make one of the two variables the same. So here I have 5y and here I have 5 square root y. So if I take equation 1 and I multiply the whole thing by the square root of 2, every term in the equation by square root of 2, we'll get 3 square root of 2x plus 5 square root of 2y equal to 20 square root of 2. Now, if we compare our coefficient in front of y in both equations, we'll notice that they are the same. All right, so if I add these two equations together, equation 3 and equation 2 together, it's going to cancel out my y terms. So we'll say equation 3 plus equation 2. So let's go 3 square root 2x plus 5 square root 2y equal to 20 square root 2. And we're going to add that to square root 2x minus 5 square root 2y equal to 8. So just like we learned long addition, we can add the terms vertically. So we'll get 3 square root 2x plus square root 2x. That's going to give us 4 square root 2x. 5 take away 5 is going to give us nothing. And at the bottom here, we can't add these two together, so we'll just be left with 20 square root 2 plus 8. All right, now just like before, we need to isolate x on the one side, which we do have, and we're going to divide through by 4 square root 2 to isolate x on its own. So we'll get x equal to 20 square root 2 plus 8 divided by 4 square root 2. Now, once again, we want to rationalize the denominator. So we're going to multiply this by 4 square root 2 over 4 square root 2. Okay, and at the top, we're going to get 20 times 4, which is 80, times 2 from the square root 2 times square root 2. So that's going to give us 168. And then we're going to add 4 times 8, which is 32 square root 2. And all of this is divided by 4 times 4, which is 16, times 2, which is 32. And we can just double check that these can be simplified. So 32 goes into 165 times. So we'll end up with x equal to 5 plus square root 2. Now what we can do is we can take this answer and we can substitute it into any of our equations and we can solve for y. And again, if it leaves us with a surd, we will on the denominator, we will have to rationalize. Okay, let's move on to another type of equation that we would need to solve. So there are two ways to solve this equation, right? The first way is to treat this as some form of quadratic equation, okay? So how we could solve this is we could say, if we treat the x as the square term and the root as the x term, so if we write this as 2x minus square root x minus 6 equal to 0, here's our x squared term, and here's our x term, right? If you square the square root of x, you end up with x, okay? And we could factorize this like that, right? So we could write this as 2 square root x, and we just need to think of the factors that would give us 1. So if we had minus 4 and we had plus 3, that would give us the minus 1 over here, this minus 1 here. Okay, and then solving, we could say, well, 2 square root x must equal minus 3, square root x equal to minus 3 over 2, and squaring both sides, we'll get x equal to 9 over 4. Same on the other side, square root x equal to 2, square both sides, x is equal to 4. So there's our two solutions. Now we need to check them, we need to put them back into the equation to make sure that they're both valid. But we'll do that in a minute, right? When it comes to surds and taking square roots, we can't just assume that the answers we're given are correct. Because when we square things, we lose information. Sometimes the answers that we get have lost information and they aren't valid anymore. Okay, let's look at an alternative way that we could have solved this, and then we'll look at which solutions are valid. So if we have a look at the way the question is given to us, we could square both sides to get rid of the root side. So if we squared both sides, we'd get x on the one side, and we'd get 2x minus 6 squared on the other side. Now we can just expand and simplify like we would normally. So we'll get x equal to, we'll get 4x squared minus 24x plus 36. And then we take the x over to the other side and we'll get 4x squared minus 25x plus 36 equal to 0. And once again, now we can just factorize. So we can think of factors of 4 and of 36 that when combined will give us 24. So we have 4 and 1 here, and maybe 9 and 4, for instance. And if we take 16 and 9, that gives us 35. So we're going to have 4x and 4 to give us 16, and 9 and 1, and we want to subtract, and so we'll get x equal to 9 over 4, or x equal to 4. Okay, and you can see both ways we get the same solution. So we got 9 over 4 and 4 in both methods, right? So they can both be used. Now we need to check our solutions, right? We need to check that both solutions are valid. So we can consider if this x was equal to 9 over 4, we'd have the square root of 9 over 4, and by definition, that's the positive square root. This is equal to 2 times 9 over 4 minus 6. This is going to give us 3 over 2 equal to 9 over 2 minus 6. And I can already see that's going to be 3 over 2 equal to minus 3 over 2, which is not valid. So 9 over 4 is clearly not a solution. And the problem here is because when we square things, we lose information, and we might have lost a bit of information. So let's check the other solution. So if we put 4 into the equation, we'll get square root 4 equal to 2 times 4 minus 6. That's going to give us 2 equal to 8 minus 6, which is 2. 2 equals 2, and so that solution is valid. And so my only solution is x equal to 4. So it's very important when we're working with any kind of surd in an equation. If we square it, we do lose information, and it's always important to go and check your answers are valid by putting them into the original equation. Let's look at one more example. So this is similar to the previous one, except we need to do a little bit of extra work. Okay, we can't solve this like a quadratic because it's not in that form. So what we can do here is we can move one of these surds over to the other side of the equation, so we have 1 on both sides. If we square this now, we're going to get a addition of squares, and that's going to produce some, it's just going to make life more complicated. So what we'll do is we'll move one of the terms over to the other side. So we'll put 3x plus 4 here, and we'll make this equal to 1 plus the square root of 2x plus 1. Now what we'll do now is we'll square both sides, remembering that when we square both sides, we're not going 1 squared plus square root 2x plus 1 squared, we're squaring everything. Right, on this side, we're just going to cancel the surd, so we'll get 3x plus 4. And on the other side, we need to remember that this is the whole side being squared. So you can write it out, if that helps you. And you can do it term for term, or alternatively, if you can spot the pattern, you can just simplify this in one go. So I can see I'm going to get 1, and then I'm going to get plus 2 square root 2x plus 1 plus 2x plus 1. Okay, here's my first, here's my middle term, and here's my last term. I've just combined the two middle terms already. Okay, from here we can simplify both sides. So I can move the 2x over, and I can move the two 1's over, and I'll get x plus 2 equal to 2 square root 2x plus 1. And now, just like the previous equation, let's just square both sides, and we'll get x plus 2 squared. And when I square the other side, I'm going to get 4 times 2x plus 1. Right, remember, you need to square everything, this and this. And now we can just expand everything, collect like terms, and solve. So we'll get x plus 4x plus 4 equal to 8x plus 4. X squared minus 4x equal to 0. And simple factor x minus 4 equal to 0, we'll get x equal to 0 or x equal to 4. Now, because we're working with an equation involving surds again, and because we've squared everything, there's the potential to lose important information, so we need to check our solutions 0 and 4 with the original equation. So if I put 0 into the original equation, I'm going to get the square root of 0 plus 4 minus the square root of 0 plus 1 equal to 1. That's going to give us 2 minus 1 equal to 1, and so 0 is a valid solution. Now let's check 4. So we're going to get the square root of 3 times 4, which is 12 plus 4. Take away the square root of 2 times 4, which is 8 plus 1. We'll get square root of 16, which is 4, square root of 9, which is 3. 4 minus 3 is equal to 1. And so both of my solutions in this case are valid.